Mollusks, Part 3. Yeah, these are hardly YouTube shorts. These are very long. Let's cover some of these minor phyla, or not minor phyla, minor groups of mollusks, classes of mollusks. So your Scaphopoda, are going to be called the tusk shells. And here you can see the organism. You see the gills are all the way up here at the end. They've got a gut that's going to go through, or rather a water channel. And so they're going to be pumping water along. They're also going to be slurping in food here. It's going to go into the stomach. And so these things have an early fossil record. They're going to appear from the Ordovician. And some of them, they're quite interesting when you see them. They're just like a little hollow curved tube. They look like a little tiny elephant tusk, but they're very small usually. There is one species I know of that gets to be massive, but I have never found one of those myself, but people have told me where they find them. So here is a similar organism. This is going to be somewhere between a Tribladida or a rostraconch, early rostraconch, or something like that. But if you take an animal like this that's got a sort of a snorkel where it's bringing in water and then spitting out water either at the end or on the side, and you just modify that and sort of merge these two tubes together. So instead of having like a body that's up here and a snorkel that comes out, you just sort of merge that, pull the body further inside so it doesn't stick out, and then you have a tusk shell, basically. And I don't really know of a better way to say it. So it could be that halcyonellids are just on the way to becoming tusk shells. They're just tusk shells with a bit of the body sticking out on this side. Yeah. Which, boy, it's possible. These are interesting, and as far as I'm aware, there's no good soft tissue preservation on this group yet. At some point somebody will find one, or maybe I've missed one in the literature, but I'd be very interested to know what was going on inside of there. All right, and so these are possible ways that they could have evolved. If you had a halcyonellid, you could imagine that figuring out how to curve a little bit faster and more and sort of curve back on itself, which is this torsion, and maybe that makes a gastropod. Like, okay. And if you had a halcyonellid that is just going to sort of elongate and maybe not move around, but go more toward a water filtering style of food acquisition, that's basically a rostraconch. There's an idea that you could separate the hinges because they look similar to the valves of a bivalve, but separation of the valves and development of a hinge, that seems like a very difficult thing to generate from a rostraconch background. You almost need to separately evolve those different valves, I would have said. And then the idea is that these rostraconch-like things, like that long, skinny rostraconch-like early creature, could then turn into scaphopods, and the halcyonellids with their sort of potential water-based, like they have at least the potential for water-based propulsion. Or you can see how if you brought in more water, if you increase the amount of water, you could end up with something which is squirt powered, essentially like a cephalopod, where they can bring in water and sort of shoot it out, squeeze it out in order to propel themselves forward. Okay. There are, in the lower Cambrian, these guys, stenothecoids. Stenothecoids have two valves, like a bivalve, but the valves are asymmetrical, so kind of like in most bivalves, but they're not articulated. They don't have teeth that lock together, which is a feature you would find in most bivalves. And the bivalves that don't have that, we believe, have come from bivalves that did have it. So it looks like the teeth are very early on. Little filter feeders. And there isn't a clear consensus as to whether these things are definitely related to bivalves. Most authors indicate that they appear not to be, the direct progenitors of bivalves, although they do have two shells. But yeah, that may be a thing that is not particularly hard to evolve. Hyoliths, look at these. So we've got one long shell, one little sort of cap-like shell, two big tentacles that come out the side. These would normally have a sort of a triangular cross section. One idea was that these are related to the mollusks that don't have any shells, the aplacophorans that then have a shell early and lose the shell later. And this is saying that there's also the possibility they're related to sipunculids, which are peanut worms. Yeah, good luck with these. I think eventually somebody may figure it out. But yeah, we have not got there yet. Here are little hyolithid parts. And so you get a variety of lids, a variety of little chambers that go on the bottom, and no clear idea of what these things are. And these would all be from the small shelly fauna of the early Cambrian. Yeah. Here are some others. These are Conotheca. So the question is, are these things related? Are these two little hooks here which form some sort of projection? Are those similar to the two little hooks you find inside of brachiopods? Were there two feeding arms there? Is this part of an articulation mechanism? Were these the attachment points for muscles that would open and close the lid? Great question. And are they related to these little bumps and prongs that you find on hyoliths? Quite possibly. What we do know about hyoliths, though, is here's a very nice fossil of one with its operculum in the open position, and you can see the tentacles coming out here. I believe this one and this one are from the Burgess Shale. I don't know if we can zoom in on this a little bit. No. Oh, yeah, there we go. In the belly of some of these, there are actually a bunch of little hyoliths. They're not really shown on my screen right now. But these Otoyas are just full of little hyoliths sometimes. So whatever they were, Otoyas thought they were tasty, and Otoyas are probably preapulid worms, which is a different kind of worm, also known as a penis worm. All right, so there you go. You got some weird things which may or may not be mollusks, but probably mollusks up to this point, and probably not mollusks from the hyoliths on, but hyoliths, I don't know. Someday we'll figure them out. We have not got to that point yet. So there we go. That's the end of mollusks proper. Now we have one more short lecture on some of the earliest Cambrian things that are mollusk-like, that are going to be in the crown group that gives us mollusks. So let's look at those in just a sec.